Let's talk about soft light and hard light. Now, before we get into how soft light and hard light work, let me show you something about the Adobe Help website. Here's their section on blending modes. And as you can see, if you scroll through here, it doesn't say anything about the formulas. It simply talks about more or less what they do, and it has some short demonstrations. So this is useful for checking things out, but it doesn't really help us when it comes to the math behind things. So the question is, where am I getting all of my formulas? Well, online, all over the place. People are always trying to figure out and recreate Photoshop's blending formulas for things like open source software like GIMP or Photopea or any of those guys. So it's a constant question, how do these do what they do, and what's the best way to emulate them? Now, that said, there's constantly arguments about soft light. While the Adobe website flat out says it darkens or lightens the color depending on the blend color, the effect is similar to shining a diffused spotlight on the image. If the blend color, light source, is lighter than 50% gray, the image is lightened as if it were dodged. If the blend color is darker than 50% gray, the image is darkened as if it were burned in. Painting with pure black or white produces distinctly darker or lighter areas, but does not result in pure black or pure white. Here's the problem. Notice that it doesn't flat out say that it's doing something like color burn or color dodge. It remains a mystery to the day that I'm recording this what exactly the formula is. There are some close guesses though. Let me go ahead and bring it up. Here we have overlay, as we were talking about a bit ago. And here we have a best guess at soft light. This is the one that comes up most frequently on Google searches. I've seen some slight variations, but as it stands, we don't know for sure what the formula is. So let's just say it's something like this. It's the active layer inverted and multiplied by the background layer that's been reduced by half. And then the inversion of that, those two are multiplied together, and in turn, it's inverted again. Oh boy, that's a lot of stuff. And remember, this isn't accurate, so let's not dwell on it too much. This occurs if it's lighter than 50% gray. Now, if it's below 50% gray, in other words, if it's darker, it will use a formula similar to this. Now, again, this formula is a best guess. It's If it's a darker color, the background will be darkened by about half and then multiplied by the foreground. This isn't right. When you start getting into it, you'll see that that's not really the case. But let me go ahead and give you a demonstration. Here we have the overlay effect, but if we switch it over to soft light, you can see that with overlay, we have a more prominent contrast occurring on everything. But if we wanted to have less of an effect going on, soft light would be the way to go about it. It has, it's more subtle. So there we have soft light. Now, what if you wanted something that was, rather than being more subtle, was less subtle? Well, we have hard light. Take a look at that. That's a very drastic effect, especially compared to overlay. Overlay, hard light. Now, there's something going on here that we should be aware of. Overlay favors the active layer, favors the background layer over the active layer. Hard light favors the active layer over the background layer. So overlay, background layer takes forefront position in all of the calculations, hence why we can see so much of the candies as compared to the gradient that we have. Oh, I also have an extra overlay. Let's shut that off just so that we have less of an effect there. That was two overlays going on as compared to just one. So with overlay, the gradient is somewhat disregarded as compared to the candy below. The candy is calculated as being more important, whereas hard light, the candy is now less important than the gradient. The background is less important. So this is, sometimes you'll see something referred to as commuted properties for things. And what that means is that if you were to flip these around, you'd end up with the same effect if they're commuted. Let me demonstrate. I will pause this for a moment and set this up for you. So here we have a set up with the candy layers duplicated twice. We've got a candy copy and a candy, a gradient over each of those. So I'm going to flip one around so that we have the candy above the gradient on the right and the gradient above the candy on the left. Now, if we were to come to the gradient layer on the left and set it to overlay, we'll have this effect occurring, which we observed earlier. Now before, let me flip this around, we were doing hard light on the gradient which was above the candy, and you can see how it's more drastic and it goes to black and it goes to white. If we were to set this to normal instead, move the candy layer above it, and set the candy layer to hard light, you'll see that this same effect is occurring on the right as on the left. That's what commuted means. It means if you were to change the position of the layers so that the one above is now below, and then affect the top layer with the commuted blending mode, you'll get the same effect that you were getting before you move the layers around. That's all. It's important to bring that up because from time to time in books and on forums and in videos, they'll talk about the commuted effect. That's all that it's referring to. Now, soft light and hard light, much like overlay, does not produce any clipping, so you don't have to worry about that. However, it's also not one of the special 8 blending modes that are affected differently by fill opacity as it is by standard opacity. So grab either of these and jostle them around as much as you want. In short, that's the hard light and soft light effect. Now, one quick thing, let's show the formula for hard light as compared to overlay. You can see that if it's over 50% midtone gray, that 128, it's affecting it the same way as overlay, 2 times, and then we've got A plus B minus A times B, all that minus 1. If it's below, same thing. On overlay, it's 2 times A times B, which is again active layer times background layer, and same deal with the hard light. Now again, the difference is just that overlay favors the background layer and hard light favors the active layer over it. Let's go ahead and take a look at what these actually do instead of just talking about it the whole time. Let's test it on this amber. So we had overlay, here's soft light, here's hard light. Overlay, hard light. It's the same thing as flipping it around. So it's almost as though we're encasing her in amber now. Soft light, it's like a softer version of overlay. Now again, like overlay, these do not work differently with opacity or fill, but also like overlay, you cannot clip with them. So that's one bonus. All right, so that's overlay, soft light, and hard light. Let's go ahead and keep going down the line. I'll see you in the next video.